Hi everyone, welcome back to my channel. Today I want to talk about constants and enumerations, or enums for short, and how you can use them in your code, how to improve your code structure to provide even more flexibility and maintainability. I will give examples in C# and Java, but if you're interested in iOS development, I highly recommend the video on enums by Sean Allen. I'll give a link in the description. And to get started, let's have a look at a basic example. In this example, I'm creating a class called request handler, whose purpose is to make an HTTP request to some URL. And it will return a Boolean, true or false, based on whether the request was successful or some exception happened during the request, and returns false. If you look at the caller for make request called test request, it's pretty simple. If my make request is successful, show success, else show some kind of error. Okay, I see this type of code very often. There's nothing wrong with it. It's usually written when we start with a basic use case and we don't foresee that we will need to extend it. But in the case of our request code, there might be multiple reasons why the request fails. And the result space is actually non-binary. It's not just true or false. We have to account for all these reasons. So one first approach to fixing this that I see often is by replacing the Boolean by some constants. And it's a very common way to do this. And if you look at older C APIs from back in the day, where you have this int error number, you can see this return from many system calls. It's quite common to address this problem this way. Now let's look at the implementation where I replace the Boolean by two integer values, one for success result, the other one for failure result. So the implementation is very similar. Instead of true or false, I return the integer code matching the success or failure code. And if I look at the test request, we can see now instead of if else, I have to have else if, because actually I made it worse, right? Because contrary to a Boolean, which only has two values, integers have a wide range of possible values. And you can see here that if we use if and else, we have to have this awkward else at the end where, you would see this often, should not happen, or stuff like that. But this is just to demonstrate our first step. And the next step is to actually add more values. So it's not just two ints to replace a single Boolean. So as I mentioned earlier, there might be multiple reasons why a request might fail. It might be a connection error, an authentication error, or any other failure case that we don't know yet. And of course, it can be successful. So looking at how I implement this, it's the same thing. When I get an exception, I check what's the type of the exception, and based on that, I return a different error code. Of course, you can implement this in many different ways. That's just one way to do it. If I look at the test request code, oh, it looks even worse now. Now I have like one else if for each of the integers, and I still have that awkward else if for failure unknown, and the else at the end where it should not happen. Okay, so it actually does not address the problem stated earlier, but actually now you have implemented an extensible system where you can support more error codes than just true or false, success or failure. And typically for HTTP, you might have HTTP status code like 200 for OK, 404 for not found, and stuff like that. We still have to handle the case where the int doesn't match any of the expected values, and that creates that duplicate case between the unknown value and the really unknown int value that we really don't know what it maps to. So even though our approach is extensible, it feels quite painful to do so. And the engineer maintaining the request handler code can easily add one more int at the top here and has no idea about the test request code that's being used below because it's from in a different part of the code base, for example. And it would be very hard to track who's using that code, that response code, and then make sure that they handle new response codes properly. Especially if, because int is generic, so an int is easily passed to like a error handler or passed up as a, my test request could return the result as an int. And eventually you lose track of where that int goes. This is not very scalable, especially in large code bases or when you're working on libraries that other people use and have no control over the way your return values are used. One way to simplify the problem and to prevent this unbounded response space is we can group all of these constants, the 4 at the top and more if we have more, into what we call enumeration, or enum for short. And both in Java and C#, these enums have an integer value associated with them. In Java, it's called an ordinal. And in C#, each enum value is an int, and an enum class is a group of ints. In this example, I have mapped each of these integer, grouped each of these integer into a response code enum, but the implementation is very similar. I replace my direct calls to the int by using the response code enum value. And if I scroll down to our caller, now I've replaced an if, else if structure by a switch case structure. What's the advantage here? So when you deal with enums, you can still use if. I can still do if result equal success or result equal failure and stuff like that. But the preferred approach is to use a switch. You can define a case here like this one for each of the enum values and have the associated logic. You can see that I've eliminated the awkward else if plus else at the end for the unknown failure, and instead I've grouped this with the unknown and a default case for all of the other scenarios, which is the equivalent of our else. If you have the ability to modify all of your colors, typically in the case where you're all sharing the same repository, I would recommend that instead of using default, you actually get rid of it and you turn your switch into what we call an exhaustive switch, which means that you are actually handling all of the switch cases. So all of the enum values in your switch have been mapped to some behavior. C# actually doesn't care about exhaustive switches because an enum is just a group of ints. But in Java, you can. In Java, you can have remove default, and then the code will not compile if you do not provide all the values. What that means is that when you use an exhaustive switch, whoever adds a new enum value, so here, if someone added a new type of failure, they are forced to evaluate each of the users of that enum to see how they should handle the new value, or they can't submit the code because it will not compile. It might feel tedious, but actually, contrary to the int approach above, actually most of the developer tools, you can right click on an enum and then find all the usage of that enum or the enum value. So even if the value is passed down or up the chain of colors, you never lose track of it. So much easier to identify where it should be replaced. I mentioned earlier that we should avoid evaluating enums with ifs and prefer a switch instead. So in this example here, if I use an if, so look at it here, line 26, I just care about the failure cases. So if it's not a success, I consider it a failure. You might think that there are no issues with that. I understand if you have 10 enum values and you only care about one, so here there are 5, I only care about non-success cases, then you might think, oh, it's okay to write this if. But in reality, what if I write a piece of code that's not a failure, error code that's not a failure, and let's say it's pending, and pending for a response that might come later as an asynchronous call or something, then suddenly that if is actually incorrect because it's not an error, it's something I need to handle. Whereas if I use a switch case below, maybe it's slightly more verbose, but actually I would have been forced to handle that pending status. For the 10 seconds or 30 seconds you save by writing that if above, actually you created code that potentially would become incorrect. So there is clearly a maintainability problem here that you could solve more easily by just using your language features like a switch case. If we go back to the previous code, so I have my enum and I have my caller with all the switch and cases. Looking at this code now, it looks okay and simple enough. But what if we want to add some behavior attached to that response value? Right now, I'm only debug logging each of the response code. I suggest we take another example that might illustrate this better. Imagine you are building some website and you want to integrate with social networks like Facebook, Twitter, or Instagram. So let's look at how that would work with constants and enums. Starting with constants, I have defined a class called social networks that will hold all of my constants of social network types. So I have 3: Twitter, Facebook, and Instagram. But I have defined 3 types of actions that you can do on each of the social networks: a post, a like, and posting a comment. Okay, so let's look at one. What does post look like? I just take in the constant representing the social network type, the type of content I want to post on the social network, and then for each of the social network type, if it's Twitter, I make an HTTP request to the Twitter API publish API. For Facebook, it would be the share API, and for Instagram, it might be upload or something. And as you notice, random arbitrary constraint, but Instagram actually requires the content to be in the body of the request, whereas Facebook and Twitter can take the content directly in the URL. As you can see, the content, the implementation starts to diverge. So I've implemented this randomly for like, the exact same way, where I take a social network type and the post that I want to like. And for commenting, where I take the social network type, the post I want to add a comment to, and the comment I want to add to. As you can see, starting to be very repetitive, but we can see that each social network has a different API signature. Some want URL parameters, others rely on the body of the request. And you can imagine that they might have like authentication systems and stuff like this that work very differently. In this case, using constant can be quite verbose. Actually, it's not much better with enums. So I've replaced my constant by an enum and all of my if else statements by switch case statements using exhaustive switches, so no default. So it looks pretty much the same. Enum, do post, switch case, Twitter, make request, same for like, and same for comment. Here, there is no visual benefits of using enums over integer constants, and we still end up with that shared knowledge of what a social network is, and that split knowledge of how social network behaves between the various services using the social network enum or constant. Replacing the enum with by replacing by an enum and exhaustive switch, that would help a bit because the code would not compile if in the future we wanted to support additional social networks. But these multiple switches on the same enum values split across multiple services should start to bug you a little bit. And in a lot of projects, people don't realize that duplication of switches because they are split across multiple places in your project. And if you end up putting all the switches in one place, like I did here, then it jumps to you, right? And you're like, okay, now I need to figure out how to improve the situation. So instinctively, you know that social networks behave differently. We have share, like, and comment, but the behavior is often associated with resources too. For example, you want to display the Twitter logo and the Twitter name in your user interface. So you might need a class like this one, social network assets, where you take a social network type and return the name based on the social network, the logo based on the social network, with some different URL based on the social network, and same for the actual website URL of that social network. You can see I just added 3 enums for very, very simple use case of having a name, a logo, and a URL for each of the social networks that we want to support. So that's 6 different switches so far that I've added for very basic behavior. It should definitely bug you. Just one side note, you notice here my get name function. I return Twitter, Facebook, or Instagram. You might not know that, but brand names are not always the same in every country. So for example, the app I'm working on at Google is called Files by Google. And in most countries, it's called Files by Google, but in some countries like India, it's called Files Geek. And I know they have other names in Latin America and some African countries. And it's pretty common for brands to change names based on the country because when these brand names come from English or other European languages, they are not always meaningful in that country. And worse, they can be even offending in that country. So you should expect that a brand name cannot simply be hard coded like this and work for every type of language. So you might need some kind of localization logic. Say if it's English, US, use Twitter, and if it's French, then use something else. Now that you've seen I added 3 more instances of the switch, we are at 6 so far, and it's becoming pretty obvious that there must be a better way to handle this. More seasoned engineers can anticipate this scenario and go straight for a better approach, but it's not always obvious when those ifs and switches are sprinkled throughout your code base. So as soon as you expose your enum publicly outside of your feature package, you basically open yourself up for this kind of issue where other engineers will just do whatever they want with that enum. And the first thing you should do, of course, is try to avoid exposing your enums publicly outside of your package. So use them internally, and outside you provide some kind of API interface or something to interact with your social networks. But if you cannot and you have to expose this, so that would be the case of my request logic earlier, then you have to ask yourself, does it really matter which social network I use? There is no special business logic from the caller's perspective about a social network. They just want to like, post, or share content. There is no like, if it's Twitter, I should like it in a different way than if it's Facebook. So from the top level API, is there a way to encapsulate that logic for each social network? Of course, the answer is yes, and let's see what that looks like. So here I created an interface called Social Network API that encompasses all the behaviors that we've defined so far. all the assets, getting a name, a website URL, the logo URL, the ability to like, comment, and add post new content. For each social network, I then create a class. So here's my Twitter API class that implements the interface. And of course, the behavior here will be specific to Twitter. So the get name will return Twitter, the website URL will return twitter.com, the logo will be twitter.com/logo. The way I like is by using the Twitter API, the way I comment is by using the Twitter API, and so forth. Same for Facebook, won't go into details because it's just arbitrary code, and same for Instagram. Okay, same for Instagram. Oops, and actually see I copy pasted it and I didn't even change the values. But let's pretend it works. Okay. Now for each social network, I have created a class that implements the interface with the business logic that is specific to each social network. So you can imagine that Twitter and Facebook have different ways of authenticating a user, for example, and having some complex authentication logic inside the previous code of here, my do post, I would have to add some, if it's Twitter, authenticate in some way, if it's Facebook, authenticate in another way before I can even make my request. So it becomes very complicated really quickly without this encapsulation. And it's even more complicated when you consider that all of these flows are typically asynchronous. So they are not run in the same thread. So it looks good and all, but it doesn't really solve our problem at the call site. The caller still needs to know what the social network is in order to post, like, or get access to the logos and stuff. So how do you allow the caller to be a bit less sensitive about what kind of social network you do? So one common approach to this is to pair this with an enum. So if I scroll down, I created this social network API manager, which takes in my enum from earlier, Twitter, Facebook, Instagram network type. And I just have a get API that takes in the type, and based on the type returns the Twitter API, Facebook API, or Instagram API. From the point of view of the callers, they might not even have access to these Twitter API, Facebook API, and Instagram API classes. I can make them package private or private altogether and just return that interface. There are other ways to achieve a similar result. You can use a singleton for each of the social network APIs. You can also have each singleton return the social network type that they belong to and put them all in a list, then iterate that list and return the matching one. You could do the same with a map. If you use a dependency injection framework, each social network API class could add itself to the map of supported social networks, and your social network manager will just check the map to see if the requested API is supported or not. So many ways you can implement this. I don't want to go into details. It might take hours to do that. But just a quick example around Java. So in Java, if your enum is not too complicated, you can use an anonymous class for the implementation and directly implement them in your social network manager. So if I go here, I switch to Java. So here I have the same enum. I have my social network API and my manager. I can directly, let's say if it was just the assets class earlier, I could use a anonymous class. I could use the anonymous class and then implement the behavior directly in there. I use this pattern very frequently for basic stuff like configuration values of between like different test environment, test, release, internal release. So it's quite common to use this kind of stuff. Also, if your enum is really basic and the behavior is the same, but the values for that behavior are different, you can also use the fact that enums are actual classes in Java and pass in parameters into your enum constructor. And then you can expose some public methods into your enum class. It's quite useful for actually grouping assets together. So if I had all the logos and the resources related to Twitter, I could put them in here. But as soon as behavior is involved, I'd rather have a class rather than piggyback on the enum class. Back to our C# example, how would the callers use our social network API? Actually, it's super simple, but you can see I have my enum, I have my 3 implementation, I have my social API manager, which returns based on the case, returns the correct API implementation. And then somewhere else in the code, I could decide to post on a single social network. So I specify the enum of network type, the type of content I want to post. That will look like this. Social manager, get API network type, post the content. Or I could post on multiple social networks as easily. I take an array or a list of network types, And for each network type, I just get the API and post, or I could post on all the social networks because now that list of social networks values is bounded. So I have a bounded list of known values. So in C# you use enum.getValues. So here enum.getValues with the type of the enum. In Java, you would use .values directly on the enum class. But the end result is the same. You get a list of all the values for your enum and you just operate on them. If you were using a map, as I mentioned earlier, you would just iterate through all the keys of the supported social networks in the map. And then for each of them, you just call that method that you want to call. You can imagine there are many ways to expand on this approach. In the previous example, we have encapsulated the behavior of a social network API inside each class. So it's very easy to add a new social network. You define a new class that implements the API. You add a new enum value, and then you add a new case in your social network API manager. None of the call sites need to change. So anybody outside of your library or your feature package do not care about the implementation details. They don't even know that you added a new social network, but suddenly we start showing up because it's added to the map of supported networks. Now, it's great, but there's still one issue is in an ideal scenario, you would not need to know the enum at all. In this case, you still need to know the social network type enum. So you need to expose that social network type to the outside world, right? Outside of that package that manages the social network API. So that's not great. So how would you go about removing that enum? So it's a bit difficult in this scenario. So let me take a final example. So imagine you are building an RPG game where your sword, for example, or any kind of weapon can do damage depending on different elements like fire, ice, lightning, etc. And you want the ability to define more elements in the future. You also want the ability to add, say, resistance to the set element. So ice resists to fire, a bit like Pokemon Stars game. And you might want to attach behavior to each of the elements. For example, an element that's a monster that attacked by an ice weapon, they might slow down, or the lightning would disarm them, or poison would linger over time. And if you use enum anywhere in this scenario, you would need to have enums everywhere in your code whenever an element is involved. So on your weapon handling code, your armor code, your traps, your spells, wherever you have elements attached to that, you will have to have this switch and enum involved. To remove the enum, you could first move the element type to a class or interface like we've defined here, and then attach that class directly into the source. So you don't care about the class itself that implements the interface. You only care that you have one element attached to your source. Let's see what this looks like. So in this sample code right here, I've defined a random player interface, some element interface with my resources for my element, so name and icon, and some generic apply to player behavior method. It can be anything. And similar to the Twitter, Facebook example, I can create a fire element class, an ice element class, and provide the corresponding behavior and resource codes for each of these elements. And then from the point of view of the outside world, outside of my package, the swords, armor, all the pieces of equipment, spells that I can do, they don't care what element it is. I don't need an enum here. I just need an array of elements of damage types for the sword or resistance types for my armor. The sword doesn't care what element it is. They only care that they may have none, one, or more than one damage types that needs to be applied to the player. If the behavior is too complicated for that interface, you can, and it involves interacting with other systems, for example, you can consider creating an element system or an element manager. And in Unity, you could easily implement those element classes. So here it's like a class like this, but if you extend scriptable object, you would be able to create those classes inside the editor rather than in code. So that allows non-engineers to create new types of elements, and they cannot change the behavior, but they can change the resource types like the sprite or image that gets displayed, the name, localize it, and stuff like this. If you're curious about scriptable objects, I recommend that you check out my previous videos on the topic. I'll leave a link in the description. All right, that's all for today, folks. I hope this was an interesting session and that you learned a bit more about how to think in terms of extensibility of your code, and maybe that inspires you to build some cool stuff, maybe some sword and armor RPG stuff. In any case, thank you for attending and watching the channel, and don't forget to like, comment, subscribe, all that stuff if you want to see more of this type of content. Okay, thank you, and see you in the next one.